All right, so we're ready to start section 2.4. So we are going to be filling out 4 pages in the notebook, but 2 of the 4 pages are just properties that you're going to need to know. So starting on page 18 are just the algebraic properties of equality that you have been using for the past 2 years, including the distributive property. And you are going to be using these to set up a algebraic proof. So again, these properties, you've been using them to solve equations for the past 2 years, so those properties should not be new. What is new is doing an algebraic proof. So if you take a look at page 19, you are going to have to make sure that you fold your notes correctly, so that way your tab is still showing. And example 1 just says solve each equation and write a reason for each step. So I know everybody has solved these equations last year in Algebra 1. So like I said, the only new piece is writing a reason for every step that you do. So if you were to solve this equation, the very first thing you should do is collect all your variables on one side. And I could do that by adding x to both sides. So if I add x to both sides, I now have 3x plus 3 equals 9. So what you want to do is write a reason for that step. Since you added the same value to both sides of the equation, then your reason is going to be the addition property of equality. So anytime you add the same value to both sides of an equal sign, that's the addition property of equality. So here's your step, and then your reason would be addition property of equality. Okay, from here, you would get your constants on one side by subtracting 3. So that gives you 3x equals 6. And since you subtracted the same value from both sides of the equation, your reason is the subtraction property of equality. And then last but not least, to solve for x, you would divide both sides by 3 and get x equals 2. And since you divided both sides by the same value, your reason would be the division property of equality. So again, this part you've been doing, you know how to solve equations. The new part that we're adding is just stating the reasons, because we're getting used to that format of a 2-column proof. So in a 2-column proof, on one side are all your statements, and then the other side is all your reasons. Taking a look at example 1b, to start solving this equation, you would first have to distribute the -4 to the 6x and the 2. So doing that gives you -24x minus 8. And that is the distributive property. And notice that the distributive property is not a property of equality, because you don't necessarily do it to both sides of the equation. Sometimes you do, but not always. So in this case, you don't want to put distributive property of equality because you didn't do the same thing to both sides. So it's just the distributive property. From here, you would add 8 to both sides so that you can get all your constants on one side of the equation. So that gives you negative 24x equals 72. So since you added 8 to both sides, that's the addition property of equality. Then to finish, divide both sides by negative 24, so you'll get x equals negative 3. And since you divided both sides by the same value, then your reason is the division property of equality. So again, you're getting used to this 2-column proof where your statements are on the left and your reasons are on the right. All right, we're going to keep going with this and opening up. You'll have still example 1, parts C and D. So part C, you have to distribute on both sides. So on the left side, when you distribute, you're left with 42x plus 108. On the right side, when you distribute, you're left with 4x plus 32. So after you apply the distributive property, you want to get your constants on one side. So to do that, you'll take away 4x from both sides. And then, just as a little heads up, I like to abbreviate a lot because I hate writing property of equality, property of equality, property of equality. That can get old fast. So please feel free, if you don't like to constantly like property of equality, please feel free to abbreviate. So a lot of times, instead of writing property of equality, I will just abbreviate that to POE. So I will just write addition, POE, subtraction, POE, division, POE, just because it gets exhausting writing this all out. So instead of writing subtraction and then writing out property of equality, you can do the same thing I do, and I just put subtraction PO. Kind of looks like subtraction PO, but it really stands for property of equality. It'll save you some time. Okay, then subtract 108 from both sides so that you can get all your constants on one side. So that's another subtraction property of equality. So notice we did it twice, once to subtract 4x from both sides and the next time to subtract 108 from both sides. So that's why it's listed twice. Then solve for x by dividing both sides by 38. So x equals negative 2. And that's using the division property of equality. So again, there's your 2-column proof with your statements on the left, your reasons on the right. And eventually we're going to be taking this format and doing geometric proofs. So this is just to kind of get used to that format. Okay, part D, we also have distributive property on both sides again. So on the left, when you distribute, you're left with 3/4 x plus 4. And on the right side, when you distribute, you're left with 63 minus 14x. Then get your constants on one side. Not constants, I'm sorry, variables. We'll do variables first. We'll get our variables on one side first, then our constants on the other side second. So since we added 14x to both sides, that's the addition property of equality. Now do your constants. And since we subtracted 4 from both sides, that's the subtraction property of equality. And then divide both sides by the coefficient, which is 14 3/4, and you'll get your answer, x equals 4. Okay, we're going to do the same steps in example 2, but this time we are isolating the variable r. So we're not going to get a numerical answer like we did in example 1. But we still have to do all of the algebraic work and then a reason for each step. So if we're trying to solve for the variable r, since it's in parentheses, the first thing I would recommend doing is the distributive property so you can get rid of parentheses. So that's 3.5 times r minus 3.5 times 5. And again, since I'm trying to get r isolated, what I want to do is bring this 17.5 over to the other side. Now, s and 17.5 are not like terms, so just write it as s plus 17.5. And since I added the same value to both sides, that's the addition property of equality. And now to get r by itself, I want to get rid of the coefficient. So I'm going to have to divide both sides by the coefficient. Now, the left side does not give me a numerical value. So don't try to simplify this any further. Just leave it alone. So it'll be s plus 17.5 all divided by 3.5. And then on the right side, that's just equal to r. We isolated the variable r by dividing 3.5 on both sides. So that's all you do. This is basically 3 steps: distributive property, then the addition property of equality, followed by the division property of equality, and now we solve the equation for r. We got r by itself. We're going to do the same thing for part B. We're going to get r by itself. So the first thing we have to do is simplify this right-hand side. So we're going to multiply 5 and 3 over r minus 5. So anytime you're multiplying fractions, a lot of people try to overcomplicate this. But 5 is the same as 5 over 1. So you're technically multiplying 2 fractions. And whenever you multiply 2 fractions, you multiply the numerators, multiply the denominators. So the right-hand side simplifies to 15 all over r minus 5. So I have s equals 15 all over r minus 5. And all I did was I simplified the right-hand side. It's not distributive property because I didn't distribute 5 to 2 terms. All I did was I multiplied 2 terms together. So that's why your reasoning for doing that is just simplifying the right-hand side. And now, because r minus 5 is in the denominator, I am going to multiply both sides by r minus 5. So there it is. Now if I multiply both sides by r minus 5, I can cancel that out on the right-hand side. Because if you divide by r minus 5 and then multiply by r minus 5, you're just going to get 1. So that cancels out. So all that's left is my numerator, which is 15. So now I have 15, and then on this side, I have whatever r minus 5 times s is. And again, I'm still trying to get r by itself. So what I'm going to do from here is get rid of this s. And the opposite of multiplying is dividing. So I'm going to divide both sides by s. So now they're going to cancel on the left-hand side, and I'm left with r minus 5 equals 15 over s. So just to summarize, first I multiplied both sides by r minus 5. That's the multiplication property of equality. Then I divided both sides by s. That's the division property of equality. And then last but not least, to get r by itself, I have to do the opposite of subtracting 5, which is adding 5. So r is going to equal 15 over s plus 5. And that's the addition property of equality. So I apologize for these 5s and these s's. They kind of look the same. So maybe what I'll do is maybe highlight or do it in a different color. So maybe I'll make my s green just so you can tell the difference. So this is an S, this is an S, 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 S. All right, so maybe that might help. I don't know. But the final answer, since we want to get r by itself, r should equal 15 over s and then plus 5. And again, I have all my reasons over on the right-hand side. First I simplified, then I multiplied both sides by r minus 5, then I divided both sides by s, then I added 5 to both sides. So that is your next page in your notebook, page 19. So page 18 has all the properties of equality. Page 19 are the examples that follow it. So the next 2 pages are laid out the same way. So page 20, you have more properties. So we have reflexive, symmetric, and transitive properties of equality. And these properties of equality are true for numbers, so real numbers, for segment lengths and angle measures. So reflexive property just means that a number is equal to itself, or a segment is equal to itself, or an angle is equal to itself. That's reflexive property. Symmetric property is basically flipping the values around an equal sign. So for numbers, you could say that if A equals B, then B equals A. For segments, if AB equals CD, then you could flip the order and say CD equals AB. Same thing for angle measures. If measure of angle A equals the measure of angle B, you could flip the order and say the measure of angle B equals the measure of angle A. Transitive is the one that's just a little bit more complicated in terms of the wording. But it's basically like you're substituting. So they're saying if A equals B and B equals C, then you can substitute and conclude that A must equal C. So that's just like saying if A equals 5 and C equals 5, then A and C must be equal. And the same is true for segment lengths and angle measures. You can kind of substitute those values in. So we are going to be applying these to the examples that are going to be on page 21. Let's zoom out. So we have example 3 and example 4 for page 21, and we're going to be using the properties listed on page 20 to go through these. So again, you want to fold it the same way so that you still see the tab. So for example 3, you're basically naming the property of equality that is illustrated in each statement. So you're matching basically. So if the measure of angle 6 equals the measure of angle 7, then you conclude that the measure of angle 7 also equals the measure of angle 6. So you want to look back on page 20 to see which property that matches up with. So what property shows that you're just allowed to flip the order? And that's right here, symmetric. So if A and B are the same measure, then you can reverse the order and say B and A are the same measure. So that's what you're going to write for example 3 part A, is symmetric property of equality. Go. Part B says 34 degrees equals 34 degrees. So which property states that you can flip around an equal sign? You could say A equals A. You could say 5 equals 5. Looking back on page 20, that matches up with this reflexive property. So for B, you want to put reflexive. And if you don't want to write out property of equality, remember you don't have to. You can just write POE for property of equality. C, the measure of angle 1 equals the measure of angle 2. And the measure of angle 2 also equals 5. So 1 has to equal 5. So this is that more complicated one. It's a little bit more wordy. This matches up with the transitive property of equality. So that's what you're going to put for C. D, segment ZY and segment YZ are the same. They're equal segments. So remember, we learned that you can name a segment using any 2 points on the line. So if this is your segment with endpoints Y and Z, you could either call it segment YZ or segment ZY. They're the same segment. So the property that says that a segment is congruent to itself is the reflexive property. So D is reflexive. Because segment ZY and segment YZ are the same exact segment. And then E, if JK equals KL and KL is 16, you can conclude that JK is 16. So that's another transitive property of congruence. Not congruence, sorry, property of equality. So basically, C and E are similar. C is the transitive property of congruence for angles, and E is the transitive property for segments. So again, C is the transitive property of equality for angles, and E is the transitive property of equality for segments. So they look very similar. And then F, PQ equals ST, so ST equals PQ. So again, we're just kind of flipping the order around the equal sign. So that's another symmetric property of equality. So A is the symmetric property of equality for angles, and F was the symmetric property of equality for segments. Okay, then going to the last example, example 4, you are now given the property of equality that you have to apply, and you're going to fill in the blank. So using the substitution property of equality, so that's back here on page 18. If x equals 20, oops, ignore the bell. If x equals 20, then x plus y equals blank. So again, we're using the substitution property of equality. So we're going to substitute 20 in for x. So x plus y equals 20 plus y. And then B, using the symmetric property of equality. Remember, symmetric property of equality says we can flip this order. So if the measure of angle P equals the measure of angle Q, then you could flip the order and say the measure of angle Q equals the measure of angle P. Addition property of equality means we're adding the same thing to both sides. So if A equals B, then A plus M has to also equal B plus M. So there it is. We're adding the same thing to both sides. In this case, we were just adding M to both sides. The multiplication property of equality, if the measure of angle 1 equals the measure of angle 2, then 5 times the measure of angle 1 has to equal 5 times the measure of angle 2, because you're multiplying both sides by the same value. In this case, we were multiplying both sides by 5. For the subtraction property of equality, if AB equals CD, then AB minus 5 has to equal CD minus 5, because we're subtracting the same value from both sides. The distributive property, you're going to distribute 8 to both terms. So if 8 times the quantity of 2x plus 1 equals 32, then distributing 8 times 2x is 16x, and 8 times 1 is 8. So 16x plus 8 has to equal 32. The transitive property of equality. If EF equals GH and GH equals 8, then you could also say that EF equals 8. And then the reflexive property just says that any angle is equal to itself. So the measure of angle XYZ equals the measure of angle XYZ. So you want to glue this onto page 21. So there you go. You have 4 pages for this section. 2 of them are just properties. So pages 18 and 20 are just listing all the properties. And then pages 19 and 21 are your examples.